So welcome everybody to our Take30 from Ironside Group. Today we're going to be talking about data readiness for generative AI and looking at getting your data assets ready to be able to use in AI technology, which is certainly a hot topic these days. Speaking today, myself, I'm Brian Platt. I'm a practice director for our data science. Jeff Spear is also here, practice director for data engineering. And Lucinda Lindy is here as senior data scientist and our AI specialist to talk about generative AI. Just so you're aware, this is a regular series that Ironside gives on technical topics. Coming up in March 14th is a Take30 on the title is Mining Data Gold Within Your Enterprise and SaaS Applications. And this really focuses on being able to access data that is within SaaS, and the traditional data access methods are more challenging. Become challenging with SaaS, and so being able to work around those and be able to get the access to the data, which really drives a lot of solutions. So that'll be an interesting talk. And for those that are really interested in the generative AI side, we've given two previous presentations that Lucinda's hosted on enterprise safe generative AI and the overall benefits the organization can derive from generative AI. And those are available on demand on our website at ironsidegroup.com/resources. So we encourage you to take a look at those, get some background on both data engineering and on the generative AI side. Just some background on who Ironside is. We are a full spectrum data and analytics consultancy, so we can help build solutions ranging from advising and designing and building roadmaps to implementation, deployment, data governance, and then management of those services to maintain the solution. And that includes, the data strategy, doing business intelligence and analytics, doing data science work and data engineering work, which are all collaborative, sort of working together features within our practice areas to build solutions. And we can also provide managed services. So we have over 20 years of experience doing this. So we're happy to help customers that can anywhere along their journey to sort of becoming data driven. Just to go through today's agenda, there's going to be just some background on the kind of the promise of generative AI. I'm sure you've heard a lot about that, and so we're going to talk about sort of the consequences and hopefully bring that into a more practical realm. And then talk about a specific use case to make this a little more concrete. And in particular, going to talk about something you may have heard about called retrieval augmented generation, a RAG framework that's being rapidly adopted as a framework to build generative AI solutions. And then get into the meat of the data infrastructure that's required to support these kinds of solutions, the philosophy behind that, and some of the key components that need to be built out in a solution. And then just talk about what the steps are that you can take to start to build yourself into an AI-driven successful company. So with that, I will turn it over to Lucinda to talk about the promise of generative AI. Lucinda?
All right. Thank you very much, Brian. Appreciate that. And yes, let's talk about the promise of generative AI. Next slide, please. So 2023 was a really interesting year because it started in January with like, hey, have you seen this generative AI ChatGPT thing? To the end of the year, people talking about how transformative generative AI and specifically also large language models are going to be. So if you look at the amount that was spent in 2023, it started from a standing start of zero on pretty much close to zero on generative AI to 20 billion for the year. And it's expected to double next year to 40 billion. In addition, business publications have really taken note and saying, like, look how this generative AI capability is changing creative work, whether it's making images or building proteins or writing blog posts. In addition, Wall Street Journal looks over it as, how also it can work with AI in general. And also it had a big impact in that the Hollywood strike, which was one of the longest Hollywood strikes, really one of the big key negotiating points was about the use of AI in these creative endeavors. Next slide, please. So specifically, Accenture did a study called The New Era of Generative AI for Everyone. And the way to read this graph is on the left-hand side, you've got the various industries such as banking, insurance, etc. And what they did was they manually selected 200 tasks from the Bureau of Labor Statistics that are parts of various occupations. And then these occupations are in various proportions across the various industries. They looked at where language only language would have an impact on specific tasks within those occupations in those industries. And what they found was that over 40% of working hours will be impacted by large language models over time. In that, for example, in banking, 54% might be automated or partially automated when using large language models, and 12% might be augmented. So it's a very large impact with very wide-ranging across industries and across functionalities. Next slide, please. So let's take a look at one particular use case so that we can kind of get specific, and I think it's instructive to look at something like this. And as Brian mentioned, to also look at the RAG framework. Next, please. So if everyone uses OpenAI ChatGPT, there's no inherent advantage. But when you pair the company data that's in your company, that includes your company's understanding of how the industry works, the best practices, the hard-won lessons of sales and manufacturing. When you take that proprietary data and you combine it with the power of LLMs, that can be a source of competitive advantage that only your company has. In order to do that, you can use this framework called RAG, Retrieval Augmented Generation, and it's a means by which to take your company data and use it to power LLM cases. And also it's important because it does not expose your company data because it's in a protected cloud environment. You can use it in a wide variety of use cases, which includes customer support, recruiting and hiring, looking at resumes, etc., marketing automation for blogs, social posts, etc. Software coding is a very powerful case for large language models. Next slide, please. So here we'll look at what parts are where. So there's something that you create called a knowledge base. That's fed into by your various training documents, which include your best practices, training resources, product documentation, etc. It also can include your customer history, knowledge of the conversation so far. You put it in a knowledge base. You then have a customer query that says, how do I do this? Or will this thing work with that thing? And then it looks at what's in the knowledge base. You pair the most relevant pieces of the knowledge base, pieces of text together with the query into an augmented query. That's the augmented part of it. And then you generate your customized response using the large language model in the form of a natural language. This can give more personalized and accurate responses. Customers will be happy. And also it's a reduced time because you're not waiting for a human to be available for an hour or two. You can now automate actually a large number of more straightforward requests. Next slide, please. So how do you do this? This slide, I'm not going to go into all the details here, but basically you can see that the data flow of for powering generative AI has some components that are separate from current data processing. You have your PDFs there on the left-hand side in the green. You then put it into a lake. There are special transformations that need to have called chunking, which is basically taking the text and putting it into small pieces, embedding, which is transforming it into the format that the large language model can understand, and the vector store. So these are really three different components from your regular data processing. But then also you've got all of your regular processing, which includes your relational databases going through the data lake and the warehouse, etc. So, but this is really just to show that it's part of the process, but there are some separate components. In order to have really good results for your generative AI application, you need to start with good data, and that includes really just getting your data estate in order. And Jeff will take us through the next part and talk about how you can actually do that. Next, please.
All right, and I'm back. So yeah, I'm going to talk about the data foundation of generative AI. One thing I will say is if you do have any questions, and I see one person has noticed this, there's a Q&A thing at the bottom where you can ask those questions, and we'll be happy to answer them at the end. Next slide, please. So LLM and generative AI benefits rely on having high quality and accessible data. So at the top, you've got your AI machine learning. to make that work well, you need to have data that has been cleansed and analyzed and sort of put into the right format for it to make use of, and we'll talk about the details of that in a sec. And in order to do that, you need a very strong foundation of data engineering and infrastructure. AI is going to answer questions based on the data that you give it. And so it's something, even more importantly than when people are reading it, because people can sometimes sort of see between the lines, AI will not. It will give, with bad data, you will get bad answers. Next slide. So, and the first thing that we promote is creating sort of a data structure and a more of an organizational paradigm that we call the modern analytics framework. And this is something where at the heart of it, we are separating the people who automate and provide data from the people who generate insights. And so in this example, you have knowledge workers who are working with these large language models to create insight, and they want to focus on that. And that takes a lot of work, a lot of different knowledge and skill has to go into just sort of figuring out what are the right prompts, what are the right things to ask, how do you need to set up those frameworks. And so what you don't want is those people worried about how to structure and organize and cleanse the data. And so you have a separate group of people, data engineers, who are good at that, and they can take care of that piece, and the two can work together, and that interface where they sort of work together is called data as a service. And so that's where the people who are automating the delivery of data make it available, and the people who are generating insights make use of it. If we go to the next slide. So in order to do that, there are some balances you have to make in terms of making data easy to use and making data easy to ingest. So at the bottom of this diagram on the right, you see the traditional data warehouse, and data warehouses are great because the data has been highly refined and highly cleansed and highly aggregated, so it's very easy to create reports from. The downside to that is that it takes a lot of work to do that. You have to do a lot of development to create that, and a lot of development to maintain it. If something new needs to be added, it's a lot of work to get that new thing in. At the other end, at the top, you have data lakes, and they're pretty much the opposite. It is very easy to put data into data lakes because it goes in a raw format, but it's much harder to get good analysis out of it generally because it hasn't been cleansed, it hasn't been aggregated, nothing has been done to it. So every time you go to generate a report, you have to redo that work, and that's not necessarily the best use of everyone's time. So on the other hand, though, there are cases where you don't need the refinement and the work of a data warehouse, but you want to do some amount of refinement, of ingest, of cleansing, of aggregation. And so that's why we have these middle zones and sandboxes. And sandboxes are really sort of temporary, so you're trying something out. And then data zones are more permanent, where you say, okay, well, we've realized that we should make these cleansing steps and we should aggregate these sources together. And that's enough for a particular purpose. Maybe the AI model needs things in a specific format. So let's create that format. We don't have to go all the way to a data warehouse. And that's responding to the inherent value in that level of refinement. And so understanding that, because those levels are going to be different for each organization. And so it's important to sort of get a sense of what the right balance is, how much I need to refine data based on what I'm going to do with it. Next slide, please. One of the things that factors into that is who's using the data. Different organizations have different proportions of these types of knowledge workers, and these are some example types. Of course, there are more. So how much you refine data for a consumer who's looking for an interactive dashboard is very different from how much you refine it for data scientists who actually might want raw data because they don't want anything to be interfering with natural patterns in the data. For LLMs, you're often going to be working with people like data engineers who are going to use specialized tools, sometimes SQL, sometimes other things, to manipulate the data. And so they're going to want it at a certain level, and they're probably going to create these sandboxes. They're going to say, okay, well, we're trying something new with Gen AI. Let's put the data in a format, see if it works. And then if that works, let's sort of promote that and put it in a more permanent data zone. And now it's something that we can productionalize and everyone can use. And so as they're doing that, they're going through these steps on the right. These are the steps that you take to generate an insight. You have to find out what data you need. So the data has to be discoverable. You have to do something to that data. Usually the data is not completely ready to go. So there's some sort of transformation that happens to it. You then look at what you did to find an insight, and then you have to get that insight out to everyone else. And then usually when you do that, you have to go back and make changes. And so what we're trying to do with this framework is make that cycle as efficient as possible. Next slide, please. So in generative AI, there are a lot of specific tasks that need to be done. So they're going to be diverse data sources. Some of them will be internal, some of them may be external feeds or data enrichment. Some of it for certain use cases may be in real time or near real time. So it may be you may be asking an LLM about something that just happened. So you have to make sure that that data has been ingested and any context for that data is available. Scalability, you have to worry about data volumes in general. You're bringing in all this data. You might be, for example, feeding in a whole lot of documents that maybe you haven't had before. So making sure you can manage that volume, but also volume from the sense of concurrent usage. So if lots of people are querying this model at once, the entire system has to be able to, fetch the relevant data for each of those requests, run the request, and then return a response. There's also a lot more use of unstructured data. That data has to be stored and, again, unstructured. So if most of your data is in a database, a relational database, that may not be the right place for it. And then Lucinda also talked about vectorizing data, putting it in vector databases, which is a way to store data in a way that is friendlier to this, the LLMs and to this resource augmented generation methodology. And those are different types of databases. And so, again, that's sort of a new thing to worry about, a new type of data zone to create. Data cleansing is important. And then also privacy, security, and ethical AI use. There are a lot of concerns about making sure that AI is being used appropriately, and transparency is important to that, so people can see and judge how it's being used. But also just worrying about security, making sure that information in prompts, your internal organizational data, PII, and other private data types stays private. There's lots of stories in the past few months about cases where that did not happen, and so it's important to spend a lot of time and focus to make sure that you don't add to those stories. Next slide, please. So one of the very important things to do that is governance. One of the things about the modern analytics framework is it tends to replace like sort of a large monolithic ETL process with a lot of smaller moving parts. So instead of going sort of straight from data source to data warehouse, the data might be stopping in a bunch of these, it stops in a lake, it might go to a different zone, it might go to a zone, it might go to the warehouse. So you have you have more moving parts, but each of them is smaller. But that does create an even higher need for governance to make sure that you're managing that appropriately. Additionally, the whole notion of refining data and spending an appropriate amount of time on the data based on its value means that as as the value of that data changes, you're going to want to change how you treat it. So in this case, we have columns that basically represent how much you're governing the data. And as you move to the right, you're governing it more and more. So in this case, you have things in the data lake. Maybe right now there's a data lake with a whole bunch of your documents in it, and there's not a lot of governance happening there. You load the data in, you sort of make sure you know what it is, you have some basic checks on it, but it's sitting in a data lake. There's not a lot to worry about. But if now we're using it for a RAG scenario, now that data is going to be made available to an internal or potentially even an external audience. So there needs to be a little bit more care about making sure that the data in there is correct, making sure that there's no company internal manuals that are being exposed to external customers, making sure that the list of documents in there is complete. It might even be the case that some of the documents are out of date and need to be updated, but you're going to start paying a lot more attention to it. And so that data is going to move to the right in this chart as it becomes more valuable and as it becomes more used. And probably in a case where you're exposing this stuff to your customers or to the internet in general, it's going to go very far to the right, where there's going to be a lot of time spent curating it to make sure that this data is good and appropriate, and if problems are found, that they're addressed quickly. And you don't want to spend time doing that to all the data you have in your data lake, because that's just a lot of time and effort spent governing data that maybe isn't that important. So you want to know what's important and what's not, so you know where to spend your time. Next slide, please. So to summarize, the modern analytics framework helps you eliminate data silos and make insights easier. It does this by making sure you have a separation between the people who are generating the insights and the people who are managing the data. Those are two very different skill sets, and you want to let each of those groups focus on what they're doing. And actually, especially in the case of insight, it's lots of different skill sets. And you do that by creating data as a service and making data available at different levels of refinement based on what different groups need and require. And so you'll have raw data in a data lake, you'll have very refined data in a data warehouse, you'll have lots of data in between. So you might say, hey, we're going to try out generative AI. Let's create a sandbox. Let's create a vector database. Let's put our documents in there. Let's see if it works, evaluate it. And then when that goes well, maybe make some tweaks and changes and productionalize it and turn that into a data zone. And now that's sort of a permanently automated thing where as new documents come in, as new context enters the situation, that data zone is updated so that the model continues to work. So that process requires governance to do that evaluation, to make sure that, hey, you made a sandbox 6 months ago, we either should shut it down or do something with it. So there's a little more organization that's required. And that's really time that you should be spending anyway, so it's time well spent. Next slide. So we have a method if the cloud data analytics is new to help with that called Ascent data, and that's basically a way to quickly develop a production-ready cloud data pipeline. It's something where if you are not familiar with how this kind of thing works in the cloud, we can help with that. If you're in the cloud but not familiar with data analytics in the cloud, we can help with that. So we can quickly say, hey, here's how the stack looks. And then if that looks good, we can say, let's implement it, let's productionalize it. Let's create something that's sort of a full system, a full modern analytics framework that you can monitor and evolves over time. So it's something where we're happy to help out. And I think the next slide is the second to last. So if you're looking to make your data ready for generative AI, you really want to focus on creating data as a service, improving your data quality, and making sure you have good governance organization. And one thing I'll add is what you do in governance is going to vary based on your organization. Governance means lots of different things like data lineage and compliance and all sorts of other areas. Your organization will need some of those things and may not need others. So understanding what you need to do is as important as which data you need to do it on. Then think about your AI use cases and see, are they using resource augmented generation? Are they data pipeline use cases? Are they more traditional machine learning? Because that's going to affect what kind of data you're going to need. And then the next step is to prepare that data. So are you creating vector databases? Are you creating feature stores? Do you have to transform or consolidate data? Do you have unstructured data that you need to bring into your data lake that you haven't had to load in the past? So understanding the use case is going to tell you what data you need and what you need to do with it. And then you have to productionalize all that. If this seems like a lot, we're also happy to do an advisory engagement where we can create a strategic AI and data readiness roadmap. Happy to help in that way as well. Please contact us after this talk. And I think with that, we are done. And so if there are any questions, we're happy to answer them at this time.
Yeah, so please, if you do have questions, put them in the Q&A. I know one thing that's come up before is the vector databases, which got mentioned a few times. Can either of you speak a little bit more about how a vector database is different than kind of traditional databases and why it's important for Gen AI?
Yeah, sure. I'm happy to do that. If you want to go to the vector database slide, that's helpful to. It's
this one.
Let me get the slide. Not that one. It's actually after the end of the presentation. So it's right. It's in the right. It's like right after the supporting slide. So keep going down.
Yeah, I don't want to go too far here.
Yep. One more.
Oh, okay.
Great. All right. So vector databases. What are they? They are a new component in your typical data landscape. And so why are they different and important? Well, one thing is they store text as numerical representations. These are called the embeddings. And that's why you need to have this transformation from your text to an embedding and you store your embeddings in the vector database. So why can't you use any old database? It's because of the stuff that you do in the vector database. So in a relational database, you're kind of looking things up by rows and columns. You might be aggregating rows, you might be aggregating columns, etc. But here, it's basically, you can think of it as a multi-dimensional space. So if you have an XY axis, and if you remember your vector, geometry, you have like one dot over here and one dot over here, both of which have coordinates, which are the numbers of the embeddings, and then you're figuring out what's the distance. And the way that the vector databases work to find out text that is near to the text of the query, it actually does a geometry measurement to say, like, okay, what are, of all these different words that are within your PDFs and groups of words, which are the ones that most closely relate to the words in the query? And then another aspect of it, so in addition to having this special geometry of how the data vector database works, it also has like this need to refresh the index. So you can imagine if you add a new document, it's not like you just like add it at the end of a series of transactions. You're basically, now it's like, oh, now this kind of changes the context of many other things. So re-indexing and syncing is another aspect of what vector databases need to be able to accomplish. And so I think that's a good place to stop here in terms of why is it different than.
If I could just add, well, first of all, add that some of us may have a harder time remembering their vector geometry than others. But also I will say that this is something where, the state of the art in the field is changing very rapidly. If you go out, you'll see lots of companies are adding vector databases, either functionality to their existing databases or adding, sort of saying, hey, you can use this as a vector database. And that's, because this area is so new and the need for this is so new, that's going to change very rapidly. So it's something where you want to, make sure you look at sort of the current research and current state of the art to see what the best ways to do this are. Because I think people are, probably still making discoveries about the best way to run these indexes and present this in a way that makes sense, both for when the LLM uses it, but also when you're getting stuff into it and maintaining it.
Right. I've got another question sort of on the embedding side that came in. So when embedding, is there a preferred algorithm or best to try a few and see which one presents the best results? And then if you're combining images with text, leveraging different schools to query, should we be thinking about partitioning the vector index with specific algorithms on the type of query? And so I think this is kind of about what's the embedding process, what's the best way to develop a good embedding process. Is that something we can speak to here? I know we've got limited time here.
Yeah, sure. I think, yes, for the vector embeddings, there's a lot of debate as to, like, should you use sentence transformers or should you do this type of chunking, etc. And it really does come down to, I think, finding out like what works with your particular use case. I imagine that in the future, as Jeff mentioned, there are so many like things are developing and things that people didn't know how to do 6 months ago, now they have like a framework for doing. So I do think that it's a good idea to keep on top of that. In terms of the combined models with the images and the words, I mean, I think that's also emerging as well. I mean, at that point, I think you do need to start looking at, okay, well, what are some of the cases that people are using? Also attending industry events, and you can find out what people say as opposed to, things that actually get on the internet. I mean, there's a lot of kind of trade knowledge that's developing right now that you can kind of access through talking to people who are working with their hands on this.
Yeah, and I would say just in terms of the image or the text versus image separation, the text models and the development around text and embedding and handling of text and the large language models generally are much farther ahead than the visual models and the image-based models. So one way to handle, if you have a lot of image data that you want to incorporate, is kind of a workaround, but one way to effectively do that is to use an LLM to get a description of your image, which sort of converts your image to text. And now you have text that you can now stick into your standard text embedding model. So you can sort of take advantage of the fact that there are ways to convert images to text using the LLM, and then use that to get all of that information about the image into the same text database as your textual information. And then that keeps it all in one spot without having to kind of mix media in the same embedded vector database. Yeah, so they're coming up is that next one. I know there are a couple more questions, but we'll try and address those separately. And but I would encourage folks that are interested to join us for the next Take 30. You can link to it on the ironside-group.com/resources page. Thank you all for coming. Appreciate your questions. Appreciate your interest.